Welcome! I'm Cassie, and I'm an engineer at Cycling74. In the last video, we talked about what Node for Macs is. In this video, we're going to look a bit more deeply at how to work with Node using the Node.script object. To do this, we're going to build a very simple game, which I have named Pixel Mover. In this game, you'll use the keyboard to move a pixel around on the screen, which you can imagine as a starting point for more complicated games. We're going to use Macs to get the keyboard input and to draw to the screen, but all of the game logic will be inside Node. So let's get started on that. When working with the Node.script object, you need two things. You need, number one, the Macs patch, which contains the Node.script object and all of the logic in there, and you need the JavaScript file. So the Macs patch needs to be able to find the JavaScript file, and one easy way to do this is to save both of these things in the same folder. So what I'm going to do is first create a new folder on my desktop. So I'm going to do new folder, N4M demo. Good, we have that. Then I'm going to open Visual Studio Code, which I guess I already have open, and I'm going to create a new file. Oh, I guess I have it down here. I'm going to create a new file, and I'm going to save this. I'm going to call it game.js. I'm going to save it desktop N4M demo. Save. Cool. So that's good. So now I can go to Macs, make a new patch, put this on the side here. I'm going to zoom in so you can see this, and then I'm going to do node.script and then reference that JavaScript file. Oh, I guess I should save this first, just so it doesn't get confused. And let's call this N4M demo. Right, so now those are both saved in the same directory. Now if I do node.script game.js, that should be good. And you can see that it was successful and that node.script could find that file because because it was able to create the object successfully. So now we can triple check this by double clicking on it and see that it gets revealed in Finder. So cool. So the next thing we're going to do is we're going to show how to communicate from our node.script to Macs. And the way we're going to do that is we're going to output some text from node.script to the Macs console. And so the first thing we need to do is pull in the library that allows us to communicate with Macs. And the way that we do that is we write const Macs API equals require Macs API. So this line of code pulls in the library that is an API to Macs. Then we use this function that Macs API has called post, and that posts to the Macs console. And we're going to put in a string. We're going to say hello from Node. Great. And so the way that we run the script in Macs is we send a message to node.script called script start. Then we send that to Node, and then lock our patch, or you don't have to, you can command click. I'm going to lock my patch, you click script start, and then if I look at the Macs console, it says node.script hello from Node. So great, we were able to post to the Macs console from our node.script. So very, very exciting. The next thing I'm going to show you is this other object with node.script called node.debug, which allows us to get output from node.script, and what we're going to do is take the left output of node.script the right output of node.script and put that into node.debug, and then when we click script start again, we'll see that we get some output from node.script, and it says running. The process was successfully started. So great. And so we can also use this to get errors in our node.script. So if we create a syntax error, I'm going to save that, click script start, and we'll see it now says unable to launch process. The process cannot be started due to the following error. And yeah, it's showing an error on the line, the Macs API.post line, where we purposefully created the syntax error. So great, let me close that, fix that again. If I click script start, great. We now see that that's working. I'm going to delete that, and now I'm going to show you how we would get data from Max to Node. So the way that that works is we send a message from Max to Node.script, and then that calls a function within our Node script. So let's write that function. So I want to be able to send this message, greeting, to Node.script. And when I send this message, it's going to call a function in here. So the way that we do that is we write, Max API has this function called add handler, right? So it's like a handler function. And then this, it takes two arguments. The first one, which is a string, which is this message, right? So those need to be the same thing. And then the second argument is a function. And so to prove that this is all working, I'm going to post back to the Max console to show that we got it. So I'm going to do max API.post. Then I'm going to say got greeting, right? Cool. So now if I go back to Max, right, I'm going to click script start again. Then if I click greeting, and if I go to the Max console, we see Node.script says got greeting. So great. I input this message to Node.script, and then it called this function. Very exciting. So now we're able to get data from Node to Max. We're able to post to the Max console from Node, and we're able to get data in from Max. So in our game, Pixel Mover, we want to be able to get keyboard input from the user, and then we're going to send that to Node to handle that and do our game logic engine stuff. So let me delete this greeting, and I'm going to delete all of this because we don't need it anymore. And now I want to show you how to get keyboard input from the user. So Max has an object. Oh, sorry. I'm going to create an object called key, right? And then this outputs some value that represents a key code. So if I hit the W key, that's 119. And that maps to 119. I hit the D key, that's 100. And we're going to use the WASD keys in order to move the pixel on the screen. So those all map to number values, and I want to only capture the number values. So if I input H, for example, I don't want to capture that because I don't care about H's. So I only want to know what the WASD keys are. So W is 119, so I'm going to write that down, 119. Then if I hit the A key, oh, you see this adder UI came up because the A is a shortcut in Max to adder UI. So if I lock the patch and then I hit A, we can just see what the key is. So A is 97. Then if I lock the patch again, S is 115. So I'm going to do CS 115. And then D is 100. So then if I do C, D, so that's just so I won't forget these values. You don't have to do that. So now what I want to do is take these number values, and I first of all only want to select those ones, right? So I need to use the select object because I don't care if I get like a T key or an H or whatever. And so I only want to select 119, 97, 115, and 100, right? So we're going to connect that together. Then I want to map these number values to strings, right? I want it to be up, down, left, and right. So I'm going to create 4 messages that are up, down, left, right. And then, so let's think about this. So W is 119, so that's up, right? Then 97 is A, so that's left. Then 115 is S, and that's down. And that means that 100 is D, and that's right. Ooh, let me move these comments a little bit so they're out of the way. So then that's right. Connect all these together. Then what I want to do is I could just input these values to Node.script and add 4 different handlers for up, left, down, and right. But I want them to all call the same function, so I'm going to prepend a value to this. That's called input. I'm going to do prepend input. Then that allows us to send a list to Node.script rather than just one string. And I'm going to show you why that's important. So let's just make sure that that's working. Connect that to a message. Then if I hit W, we see we get input up. D, we get input right, and so on. Great, so that's working. So now I'm going to input that to Node.script. And the cool thing about add handler is that if you send a list rather than just one string, then you can add parameters to the function in add handler. So if I do max API dot add handler, and then I do input, right, because that's the name of the function we want to call, that's their input value, and then I create a function, and then dir allows us to get the dir short for direction. That's going to give us this value, and so I'll prove that to you. So if I go, if I write max API dot post, I'm going to write, I'm going to string interpolation. I'm going to do how do you spell received? Received, oh, okay, received from max, and then I'm going to put dir, right? Great, so let's make sure this is all working. So I'm going to lock my patch, I'm going to hit script start, and then I'm going to open the max console, and if I hit W, D, S, A, right? I'll see we have a bunch of up, right, down, and left. So that's all working. Very, very cool. The next thing I want to do is I want to take these values and, well, what do I want to do with these? Up, left, down, and right. So we're going to store the position of the pixel on the screen in some variables, right? We want to store the X position and the Y position. So I'm going to create two variables. I'm going to call one of them X, and do let X equal 0 and let Y equal 0, right? Then what I want to do is, based on what the value of dir is, I want to change the X and Y values, right? So if I get up, for example, I want to increase the Y value, or if I get right, I want X to increase, I want X to get greater, and so on. This is assuming we have a game in which X is increasing this way for you, right? And Y is increasing this way for you, right? Okay, so let's write some if and else statements to handle that. So I'm going to delete this. We don't need that anymore. I'm going to do if dir equals 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 up. Great. I'm going to write all these if else statements out first. I'm going to do else if dir equals 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 down. Else if dir equals 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 left. Oh, I don't want that to be in the body. Else if let me scroll up a little bit so you can see that. Else if dir equals 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 right. Cool. So then in here we're going to fill in some stuff to handle these different values. So if we get up, we want to increase our Y value, so we're going to do Y equals Y plus 1. You could also use the syntax Y plus equals 1. I prefer the syntax, so I'm going to do that. Then for down, I want to decrease Y, so I'm going to do Y minus equals 1. Then if we get left and right, I want to change the X value, so I'm going to do X. If it's left, I'm going to do X minus equals 1. If it's right, I'm going to do X plus equals 1. So now let's inspect the values of X and Y, and let's just post that to the max console so we can see what's going on. So I'm going to do max, let me scroll up a little bit, max API dot post, and we're just going to do X colon X, Y colon Y colon Y. Great. So now what I want to do is go back to max, lock my patch, hit script start, then open the console, and let's see if this is working. So if I hit D, right, we'd expect our X value to increase, and if I hit W, Y value to increase, and if I hit S, Y value decreases, and A, X value decreases. So great, that's all working as I would expected. So I've shown you how to get data from, I've shown you how to output to the Max console from Node, but I haven't shown you how you would actually get that data in the patcher itself. And so the way that you do that is you use max outlet. So if I do max API.outlet, this is the function we need to call. And then I can just pass X and Y. And then in max, those will be sent out of this outlet here, and it's going to be a list. So by connect a message box, we can now see what that looks like. So I'm going to save this. Then I'm going to go back to my max patch, lock it. I'm going to hit script start. And then if I start hitting the WASD keys, we'll see that I'm getting values here, right? So here is X increasing. I'm hitting the D key. If I hit the W key, we see that Y is increasing. Then if I hit S, Y is decreasing. And then right, our A is decreasing. So A, the X value is decreasing. So great, that's all hooked up together. So now that we're able to get this data, these variables from the node, from our node script, now I want to show you the last little bit of drawing code, right? We need to figure out some way to show our little pixel friend on the screen. So the way we're going to do this is we're going to use a couple of jitter objects. The first one I'm going to do is create is a jit.p window. And this is just an object that allows you to visualize a jitter matrix. And so I'm going to make this a little bigger. Why is my little dude not coming up? All right, it's not working for me. Oh, there we go. There we go. It's like, why isn't this little resizer thing coming up? There we go. Make it a little bigger so you can see it. Now we want to create the actual matrix that's going to define what is being shown on here. And so our little visualizer, our pixel's just going to live in a 20 by 20 pixel world. It's only going to be grayscale, so we're just going to create a matrix that we're going to do jit.matrix. And then this takes a couple arguments. The first one we need to put is one char, and that means that our matrix, at each position, it only stores one character value, and that means we can put a grayscale value from 0 to 255, and then we're just going to put 20, 20, which is 20 pixels, which is the width and the height, which is 20 pixels by 20 pixels. So put that there. That's all good. And so now let's think about how we would set an actual value in our jitter matrix. And so jit.matrix takes this message called setCell, and the arguments for this are some position. I'm just going to put a random position just to show this is how this works, which is 3, 4, and then you need to put a value in. So you do val 255, and this 255 means that it's weight value. So that value represents weight. So I'm going to connect this to jit.matrix. Then if we think about this for a moment, like let's say we have the pixel drawn on the matrix. Let's say our pixel is at like some other position, right? When we're setting the value of our pixel to a new position, we only want to set that pixel. We don't want our old value to linger around, so we need to set all of the pixels to black first. So I'm going to create another message that's called setAll. I'm only going to give it one argument, which is 0. And that means setting all of the cells in the matrix to 0. The last thing we need to do is, in order for jit.matrix to output its value to the jit.p window, we need to send a bang. So great. So let me show you this all working. I'm going to click setAll. Then I'm going to click setCell, then I'm going to click bang. And we can see our pixel now has a value. And if I now edit this and I make this like 3, 7, right? And then I do this manually again. I click command, or I command click setAll, command click setCell, click this bang. And we see it now moved, right? So it's all working together. Very exciting. The last little bit we need to do is get this value and somehow translate it to a position on the jit.p window. So how do we do that? We need to output this list to set cell and like set it to these values. And we can do that by using max variable substitution, which is this $sign syntax. Just do $1, $2. And then remember how I was clicking all of these manually? What I need to do is have a little like series of events, right? I want to click this, and then send this bang, right? And the way to do that is to use this max object called trigger, and then you send it the series of things you want to output, right? So you do trigger, and then so the first thing I want to do is send a bang for this. Then I want to actually output the list, right? And then I want to send a bang. So I'm going to do trigger, bang, L, bang, right? Because the input to this is going to be this list. And then, all right, I'm going to connect all these guys up. So, and also remember that in Max, you have right to left ordering for series of events. So this one is going to output first. So I'm going to connect that one, then this one. I don't need this bang anymore. I put that there. And now I think this should all just work. I'm going to click script start again. Now I'm going to click the WASD keys, so I'm going to hit the D key. We now see that our pixel is moving. So now if I hit the W key, we see if I hit the W key, it's moving down. If I hit the S key, it's moving up. That's a little weird. And so the reason for that is that in jit.p window, the Y, the increasing Y, is actually down rather than up. So what I'm going to do is in our game logic code, I'm going to just switch these Y values. So I'm going to do Y minus equals 1 for up and Y plus equals 1 for down. And then that'll map to our actual keyboard, our WASD keys. So now I need to go back to Max, hit script start again to refresh the JavaScript code. And then if I hit S to go down, that's working. And if I hit W to go up, that's also working. So great, our pixel mover game. I can use the keyboard, I can use the WASD keys, and I can move a little pixel on the jit.p window screen. Very exciting. So let me just talk through everything that we did in this tutorial. So the first thing to get all this game working, we use the keyboard input using the key object to take a key number value. We only selected the WASD keys. We mapped those to string values, which are up, left, down, and right. We then prepended those with input so that we could call the input handler function in our JavaScript. Then we sent that message, input up, input left, to our node script. Then in our node script, we stored the position of the pixel in x and a y variable. Then based on this dir parameter, we increased or decreased the y value. And then we used our max API.outlet to output those x and y values back to our max patcher. Then we used a jit.matrix and a jit.p window to visualize this pixel position by sending it the message set cell to set that value, and then before that, making all the pixels black, and then banging it to flush the output to our jit.p window. So there you have it, pixel mover. You can imagine maybe you'd want to make this a little more complicated. For example, like the pixel can like escape off the screen if you make the values negative, or it's like too positive, right? It's off the screen. So maybe you want to add some constraints. Maybe you could imagine like a snake game where this pixel is moving and you want to use the WASD keys to keep it from hitting the edge. Maybe the tail would increase. You could like pick up fruit and stuff. I don't know, I haven't played Snake in a while. So you can imagine doing something like that, maybe having more pixel friends that I could go with. There are many, many possibilities for this game. So I hope you've learned about some basic tools for working with Node.script in Max. And I hope to see you again in the future watching more Max tutorials. So thanks for watching.